Hello Year 7. Today it's going to be the test review. Hopefully you had a great half term. If you haven't managed to do the test yet, could you go into February's work and get the test, do the test, and then green pen it for me, please. So I'm going to go through and give you all the answers so that you can green pen it as I go along and talk. Now, what you might have to do is, if I go too quickly, is just pause it like usual. But for this one, let's start. So an object made from copper is a saucepan. What is the reason for using copper to make that saucepan? Well, you need a good conductor of heat. For the coin, why do we use copper? It does not rust. And for wires in a cable, why do we use copper for that? Copper is a good conductor of electricity. Now, brass is a mixture of copper and zinc. Some keys are made from brass. Why is brass more suitable than copper for a key? Well, brass is an alloy, so it does not bend as easily. Okay, and again, because it's an alloy, it is harder. Right, zinc melts at 420 degrees, and copper melts at 1085 degrees. So a scientist heats the dish with zinc and copper pieces into 600 degrees. What would you see? Well, 600 degrees is above the melting point for zinc, but below the melting point for copper. So zinc should melt, copper will not melt. So let's say we'll have liquid zinc and we'll have solid copper. So where's that? Liquid zinc and solid copper. There it is. Question 2. Here are some properties that elements can have. Which two properties from the list make aluminium suitable for saucepans? Well, it's going to be heated, right? So we need very high melting point. So this is 1. So V high melting point. And the other thing about aluminium is that it's a good conductor of heat. Okay, so this is 2. Good conductor of heat. So, which property in the list above explains why copper is used in the cable of a television? Well, for B, it's a good conductor of electricity. And which property explains why a lot of oxygen gas can be pumped into a very small container? Well, this is because oxygen gas can be compressed. Okay. Question 3. Table below shows information about 5 elements. Which 2 elements are likely to be metals? Well, the answer is C and E. But let's have a look. Very high melting point, very high boiling point. Very high melting point, very high boiling point. Okay. Conducts electricity. So these are the only 2 here that conduct electricity, which is probably the most obvious one that shows you that they're a metal. They've got the 2 highest melting and boiling points. And this one's silvery, which kind of gives you an idea because metals have to be silvery. They reflect light, so every type of metal you'll be able to see some sort of reflection on it. So which element is a liquid at room temperature? So room temperature is about 20 degrees. So let's have a look. So 20 degrees has to be in between the melting point and the boiling point. If you look, this one here is the only one that has 20 in between these 2 numbers. Okay, so it's A. What is the correct symbol for copper? Well, that's capital C, lowercase u. Now, the next one, I think some of us misunderstood the question, and some of us pretty much got it bang on. So, if I have two different types of iron oxide, so here's the first iron oxide. I'm going to draw it out. It is one atom of iron, and it is one atom of oxygen. This second type here is two atoms of iron and three atoms of oxygen. Okay. So how many atoms of iron is in the first one here? Well, there's one atom of iron and there's one atom of oxygen. If you didn't want to draw it out, remember that if there isn't a number afterwards, it counts as a little 1. And for the second one, there are 2 atoms of iron and there are 3 atoms of oxygen. Okay, question 4. Samantha opened a tin of white paint. What type of substance is the paint? Well, because you can see that these two layers have separated, this substance must be a mixture, right? What type of substance is titanium dioxide? Right, because this ending here, IDE, that "ide" ending, that tells you that this is a compound, right? If it was titanium oxygen, that would just be a mixture. But because it's titanium oxide, we know that it's a compound. Why did the particles of insoluble titanium dioxide sink to the bottom? You need to say, I would have said that it is more dense. And it has to be density. You can't say anything's heavier, or like, you have to say that this is more or higher density. Okay, the titanium dioxide has a higher density than than the liquid. Or the liquid has a lower density than the titanium dioxide. So, here Samantha gets paint on her window. You can see she's a bit sloppy. She's got paint everywhere, right? She can't get the paint off the window with water, but she can get it with white spirit. So why does the white spirit remove the paint, but the water does not? So, there is basically, what this is getting at is that water does not dissolve the paint. Okay, it doesn't dissolve it, but the white spirit does dissolve the paint. Okay, I'm sure if you ever done any painting at home, and you've had to clean your brushes, you might give them a rinse and soapy water, but then if it's really stuck on, you'll get some white spirit, which is a very strong smell, and you'll leave your paintbrushes to soak in there. Okay, so you need to say that water is not a solvent for the paint, but white spirit is. Or the paint will dissolve in white spirit, but not in water. So I'm going to say the paint dissolves in white spirit. Okay, question 5. A teacher mixed iron filings with sulfur on a tray. She heated the mixture in a fume cupboard. Sulfur is yellow, iron filings are grey. So give one way that you can tell this chemical reaction took place. Well, let's have a look. The mixture glowed very brightly. The teacher turned off the Bunsen burner. Then the glow spread through the mixture. When the mixture cooled, the black solid, called iron sulfide, was left. So, first thing, after the teacher turned off the Bunsen burner, this glow spread through the mixture. That tells you a reaction's happening. And then when the mixture cooled, a black solid is left. That tells you that a reaction has happened, because sulfur is yellow and iron is grey, and neither of them are black. So take your pick. You've got a choice between the mixture glowed, or you could say there was a colour change, or you could say a black solid formed, or a new substance has been formed. I like the easiest one is there was a colour change. Okay. What type of substance is each of the chemicals involved in this reaction? Choose from these four. So iron. Iron is a metallic element. Sulfur is a non-metallic element. And iron sulfide, remember that ID at the end there, that means this is a compound. So, Raj held a magnet near to the end of the three chemicals. Right, yes or no to see if it was magnetic. Well, we know sulfur is not magnetic, and we should know that iron is magnetic. When iron is heated with sulfur, iron sulfide is formed. Give the name of the solid when zinc is heated with sulfur. Well, if iron plus sulfur makes iron sulfide, zinc plus sulfur makes zinc sulfide. So complete the word equation for this reaction. Sulfur plus oxygen, and that will make sulfur dioxide. You are given the mark if you said sulfur oxide, because it's technically correct. It's just not as common to make sulfur oxide. It's more often you make sulfur dioxide. But you don't know that yet because you haven't learned about structure and bonding, which is a GCSE thing. Okay. I'm going to skip past the graph one because not many of us were able to draw it because we were doing it from home. We'll have plenty of practice at plotting graphs in the future anyway. Now, just so you know, you could have done a labeling of the axes, sorry. So the mass of magnesium, so this is the mass of magnesium in grams, and on the y-axis it is the mass of magnesium oxide. Okay, this mass of magnesium oxide in grams, mass of. Okay, the easiest way is this column. Where's my pen gone? There it is. This column is the thing that you are changing, right? This column here. So when you do tables in science, you always put your independent variable on the first column. Now that means that this will always go on the x-axis and this will always go on the y. So if you're ever given a table and a graph and it says draw this graph from the table, this first column, the label from that column will always go there. The second column, the label usually goes here. Now if there's more than two columns, you've got to figure out which one, but generally the first one's always the x-axis. So I'm going to skip past this because not many of us could do it. So, question 7. So you've got a bit of copper powder in this tube here. So you've got copper powder in here. You're heating the copper powder, and then when the copper is hot, you push some air across the copper and you keep pushing it backwards and forwards. Okay, this is kind of like a really controlled way of doing an experiment. What they're trying to figure out is how much of what volume of oxygen reacts with the copper. Now, it says here it started at 100 centimeters cubed, and then at the end of the experiment there was only 79 centimeters cubed left, right? Now, why did the volume of air decrease? Because we had copper in there and it reacted with the oxygen. So what I would write is copper reacted with the oxygen. Now, if you didn't know that copper reacts with oxygen, from this experiment, they've given you enough information for you to figure out that the copper, this copper here that they put it in this tube, has reacted with the dry air. So you could have said copper has reacted with the dry air. Now, why did the volume of air not decrease below 79 centimeters cubed? So they do this reaction, and they keep going, and eventually it goes down to 79 centimeters cubed, and they keep going, and then nothing happens, and they keep going, and nothing happens. So what they're saying is, or what you would say is, if you were doing this experiment, you watched it for long enough and nothing happened, you would say the reaction's finished, or the experiment's finished, okay? So you could say that, well, there was no more oxygen left. Maybe if you worked out, you did the maths, you did this, take away this, you would have found that there was 21 centimeters cubed of oxygen. So why did the volume of air not decrease below 79 centimeters cubed? Well, the reaction had finished, or everything that had reacted was gone. So in this case, there was no more oxygen left. Because remember, the air that we've got around us, there is some oxygen, there is some carbon dioxide, there is lots of nitrogen, and then there's some other stuff as well. Now this is the only thing that reacts. In this case, carbon dioxide and the nitrogen and the other stuff don't react. So once all the oxygen's gone, the reaction will stop. So the surface of the copper was seen to be black at the end of the experiment. What is the chemical formula? Now, copper oxide. So unfortunately, if you wrote copper oxide, I'm not sure if I gave you the mark. I think I may have done. But generally, because it said chemical formula and not name, you had to write CuO. So what type of reaction? This is an oxidation reaction. Oxidation. Right, that copper started off as copper and it gained oxygen. Gain the balanced, write the balanced equation. Well, you again, 2 coppers plus 1 oxygen makes 2 copper oxides. Now, these 3 here, I would not have expected many of you to get, because this is like the GCSE overlap question. The first 2 marks, possibly. But those 3 that I've boxed, if you got any of those, then I would have been very impressed, because it's GCSE knowledge that you haven't learned yet. So, question 8. So John Dalton, he said, all substances are made of a vast number of extremely small particles called atoms. Every particle of water is like every other particle of water, and every particle of hydrogen is like every other particle of hydrogen, etc. So part A, the first statement. Use Dalton's ideas and your knowledge of water to explain why. Well, hopefully we remember that water is H2O. We've heard that before, and hopefully we know that that means that there's 2 times a hydrogen atom for every 1 times an oxygen atom. So use this idea that he's just said to explain. Now all you had to say was, well, every water molecule will have the formula H2O. So every water is a H2O. Or if you wanted to put it into more words, you would say every water has 2 hydrogens and 1 oxygen. You're just getting that statement and applying it to a molecule, and you're kind of stating the obvious, but you'd have to know that water was H2O. Right, again, B. This one you would be able to do. Sorry that these were a little bit misaligned, these 2 statements here. It says, state in terms of the particles, how are these 2 atoms different? Now, if you knew the names of them, that would be very good, because we'd learn a little bit about protons, neutrons, and electrons. But if you just said that atom B didn't have that black particle here, so atom B had the black particle, but atom A didn't, but otherwise they're identical, I would have given you the mark. If you look, atom A and atom B both have one of these. atom A and atom B both have one of these, but atom B also has this. Okay, so even if you don't know what they are, what the names are, if you're comparing the difference, you can see that that is the odd bit out. Now this is actually called a neutron. So you could have put an arrow and said atom B has this, but atom A doesn't. I would have given you the mark, but I don't think anyone managed that one. But that black shaded particle is called a neutron. So you would say atom A has no neutron. Right. And these are our bread and butter definitions. What is an element? Substance that contains one type of atom. Okay. And what is a compound? So it is a substance that contains two or more different atoms bonded or joined together. I'm going to write bonded because that's the more correct scientific term. Now this is the word for word definition we need to remember. So a substance that contains two or more different atoms bonded together. They're the three really important points. I know it's only worth 2 marks. So now you've done your green pen, just take a photo of it and take a photo of one of the pages that you've done it on, send it to me in an email, and then you're all sorted.